For this first lesson of the equations unit, we're going to talk about adding and subtracting one-step equations. So first off, we need to talk about what an equation is. An equation is a sentence stating that two quantities are equal. And then a solution is the value of a variable that makes an equation true. So basically, we are solving equations to find out what value is true for it. And the difference between an equation and an expression is that an equation has an equals sign. So how do I solve an equation? The first thing that we're going to have you do is to draw a line through the equal sign to show both sides of the equation. Then we're looking at the side that has the variable on it. We ask ourselves what operation is being done to it, and then we do the opposite or the inverse of that operation to both sides. So what I want you to do is to look at these two parts right here. This is really, really important. So I'm actually going to highlight this. You must do the same thing to both sides of the equation, and you must show all work. We are more concerned about what your work looks like than we are about the answer, because it's really important to show that you're keeping both sides balanced. Once you've done that, you need to rewrite your answer in x equals some number or some number equals x. And then we're going to use our calculator to plug our answer back in and to check to make sure that it is correct. So what are inverse or opposite operations? Well, the opposite of addition is subtraction. And the opposite of subtraction is addition. So what that means is if there's an addition sign in the problem, we're going to undo it or do the opposite of it, which is to subtract. Or if there's a subtraction sign in the problem, we're going to do the opposite to solve it, which is to add. So let's look at the first problem. Number 1, we've got x plus 101 equals 472. So the first thing that we want you to do is to take that equal sign, draw a line down the middle. So that's showing you one side of the equation and the other. Then we're looking for the side of the equation that has the variable. So if I look over here, our variable is on the left side of the equation. And then we're looking at what operation's being done. We have the operation of addition. So we need to do the opposite of that, which is to subtract. Well, what were we adding? We were adding 101, so we're going to subtract 101 from this side. Because 101 minus 101 is going to cancel out. Well, if I subtract from this side, the only way to keep it balanced is if we subtract from the other side. Then, step 4 was to rewrite the answer in the form x equals or something equals x. Well, on this side, these numbers canceled out. 101 minus 101 is canceled. So the only thing that we're left with on the left side is x. We'll bring down our equal sign, and on the right side, 472 minus 101 is going to give us 371. We have our variable on its own, so that means we have fully solved it, and we have our answer, x equals 371. Well, the big thing that we want you to focus on, too, is checking your work. We're letting you use a calculator, so there's really no reason you can't check over your work and make sure that your answers are correct. So what you're going to do is you're going to take your answer and plug it back in for x. So we have 371. We're going to plug it back in where x was. So 371 is x plus 101 equals 472. And then all I'm going to do is on my calculator, I'm going to plug that in. 371 plus 101. Does that give me 472? Yes. So I'm going to say 472 equals 472, and I'm going to check that we're good there. All right, example 2, 34 equals x minus 63. So again, first step is to draw our line down the middle of the equal sign. and we're looking at our two sides of the equation. We want to look at the side that has the variable, which in this case is on the right side. Once we've identified that, what operation is occurring? We have subtraction, so we need to do the opposite, which is to add. So if we were subtracting 63, we're going to add 63 because those are inverses and they cancel each other out. If I have negative 63 and positive 63, it cancels out to 0. Well, if I add 63 on the right side, I also have to add 63 on the left side. So on the left, 34 plus 63 gives me 97. The minus 63 and positive 63 canceled out on the right side, so the only thing that we are left with on the right is x. Since x is now alone on one side of the equal sign, that is our final answer. But again, we want to go back and double check to make sure we didn't make any mistakes. So we're going to plug in. We're saying x is 97. So we're going to plug 97 in for x. So we have 34 equals 97, which is x, minus 63. So again, getting out my calculator, 97 minus 63. Is that going to give me 34? Yeah. So 34 is equal to 34. That is a true statement. I did not make a mistake. So those are two with whole numbers. Let's look at two problems that have decimals in it. So example 3. X minus 96.5 equals 127. So again, first step, draw that line down the middle. Now we're looking at the side that has the variable. This case, the variable's on the left side. We see that the operation is subtraction, so the opposite of subtracting is to add. So if we have minus 96.5, we're going to add 96.5 to both sides. Again, you have to do the same thing to both sides. Now we need to rewrite. Well, let's look. If we had minus 96.5 plus 96.5, that cancels out to 0. All that's left on the left is x. And then on the right side, 127 plus 96.5 gives me 223.5. X is alone. That means we finished solving, so that is our answer. Now let's go back and check. I'm going to plug this in for x, so we're going to plug in as if 223.5 is x minus 96.5 equals 127. Let's see if that is true. So 223.5 minus 96.5, and we get 127. So that was a true statement. It worked. Number 4. 13 2/10 equals x plus 1.5, or 1 5/10. Step 1, draw our line down the middle. Step 2, find the side with the variable. In this case, the variable is on the right side. Look at the operation. We are adding 1.5, so the opposite is going to be to subtract 1.5. If I do that on the right side, I also have to do that on the left side. Then we need to look at rewriting. So we've got 13 2/10 minus 1.5. If we subtract that, we get 11 7/10, 11.7. On the right side, we have positive 1.5 and we subtract 1.5. That cancels out to 0. All that we are left with on that side is x. X is alone. That means we are done solving. So let's go ahead and check our work. If I plug in, we've got 13 2/10 on one side. Plug in for x, 11.7 plus 1.5. Well, let's calculate that. 11 7/10 plus 1.5. We get 13.2, which is what we were saying it was equal to, which means our answer is correct. All right, we did two whole numbers, we did two decimals, Now we're going to look at two fractions. So for number 5, we're going to do x plus 3/4 equals 7/8. So we know all of these problems were addition and subtraction problems. So what that means is when we're working with fractions, we need common denominators when we add or subtract. So the first thing that I'm going to do before I even try to do any solving is I'm going to rewrite the problem. But instead of having different denominators here, I'm going to convert so they have the same denominators. So x plus what? Well, 4 and 8, their least common denominator is 8. So how do I convert 4 to 8? 4 times 2 is 8, so 3 times 2 is 6. And then the 7/8 is already 8, so we can keep it that way. Now I'm going to actually solve. So I'm going to look at the side with the variable. In this case, it's the left side. We are adding 6/8, so the opposite is going to be to subtract 6/8. Well, if I subtract on the left, I need to subtract on the right. And then we need to rewrite it. So if I have 6/8 and I take away 6/8, that cancels out. I am left with just x on the left side. And then on the right side, 7/8 minus 6/8 is just 1/8. So it can be a little bit trickier to check with fractions, but we can still do it. Instead of plugging it back into this original equation up here, I'm actually going to plug it into this second equation here. So I'm going to plug in 1/8 to this equation here. 1/8 plus 6/8 equals 7/8. Well, 1/8 plus 6/8 is 7/8, which was our answer. That means we did it right. All right, we're going to do one more fraction problem and then go on to the U tries. So number 6, we've got x minus 5 1/6 equals 2 4/15. So step 1, draw the line down the middle. Step 2, before I do anything else, I'm just going to convert right away. So again, we need common denominators. 6 and 15, the lowest number they both multiply into is 30. So I'm going to rewrite this. X minus 5, our denominator is going to be 30. 6 times 5 is 30, so 1 times 5 is 5, equals 2, and we need our denominator of 30. 15 times 2 is 30, so 4 times 2 is 8. Now I can actually get into solving. The side with the variable is on the left. If we are subtracting 5 5/30, we need to do the opposite, which is to add 5 5/30 to both sides. On the left side, they're going to cancel each other out. I am left with just x equals 8 plus 5 is 13/30. 2 plus 5 is 7. So again, when I go back to plug it in, I'm going to plug it into our rewritten one with common denominators. So we have 7 13/30 for x minus 5 5/30. Does that equal 2 8/30? Well, 13 minus 5 is 8/30. 7 minus 5 is 2, which is exactly what we have there, so our answer is good. So last step is to try the U tries. The first one is 203 equals x plus 17, and the second one is x plus 1/6 equals 7/9.